Okay, this is called inverse trig. You might be saying, didn't we already do inverse trig? We did some inverse trig. We did things like this, where we would go, oh yeah, this is sine of theta equals 10 over 20. But then what do you do to get that actually solved? You know, get the sine off of here. Yes? Do you remember?
Me?
Yeah, I thought you were raising your hand, but apparently not. Do you know how to get sine off of here? Hint, it's the title of the chapter. Yes?
You multiply it by
Inverse sine, very good. The way I would say it is you take inverse sine of both sides, because you take the inverse sine of 10/20ths. All right, sine and inverse sine cancel each other off, theta's alone, and I got an inverse sine of 10/20ths. 10/20ths would reduce to a half, wouldn't it? But now my job is to actually tell you how to get that answer. Like, how do you get that answer? So I'll show you. This is inverse trig. And we're going to need to remember circle trig first, though. So what is the sine of pi over 4? Well, that's circle trig. Everybody draw the triangle in the right quadrant. Do that right now. Draw the circle. Find the right quadrant for it. Draw the line. Draw the triangle that goes with it. And then I'll remind you about how to find the quadrantals. We got to have all of the circle trig just like at your fingertips, because inverse trig boils down to circle trig with restrictions. Okay. Did you remember that pi over 4 was there and it was like a 45-degree angle? Good. Did you draw a little circle and call this A, S, T, and C? Maybe you didn't because you were like, I don't need to, but it's actually really smart to do that. And now I'll be reminding you why. And then this, if you know this is pi over 4, you know it's 45, and then you know this is 45, and then this is 1 and the square root of 2. And what is the sine of that then? Well, it's the opposite over the hypotenuse. Opposite, hypotenuse, 1 over root 2. And that's the answer. Was this an inverse trig question? No. You don't see the little -1 powered, do you? Okay, so that's just a regular circle trig question. And there was only one answer, and it was 1 over root 2. All right, next thing I want to remind you about is if I said sine of theta is a half, that is completely different. I'd like you to draw sine, not with all of the complicated, just make a wave and make it go in both directions. You guys agree that's sine? Okay, draw this out. This is going to help you understand what we're doing. Okay, that's sine, but where is a half? Well, if you know that the highest sine ever goes is 1, and the lowest it ever goes is -1, would you agree that our line would be like through here at about a half? So when I'm answering this question, it appears like I'm going to have two answers that are fairly close to each other, and then even more answers over here, and if I kept going, even more answers over there. There's an unlimited number of answers. But usually, do you remember we'd say, just give the answers between 0 and 2 pi? That was artificially saying, I only care about this zone right here. Do you get how we were restricting and we only wanted 2 of the answers? Okay. In inverse trig, it restricts it even more. Inverse trig, we restrict it to down around here somewhere, and I'm being vague because it depends on what function you're in. But inverse trig restricts it even more. You only use a tiny bit of the function. Now, I'll explain why in a minute. All right, so if we're going to finish this problem, sine of theta equals a half, I need 2 answers for it. So everybody make sure that you draw 2 triangles for this, because there's 2 answers. Draw 2 triangles in the circle. Is this inverse trig? No. But you have to understand this. We do this every time we do an inverse trig question. We do a circle trig question with restrictions. Okay, so ASTC. Is sine positive here? Yes, it is, because this number is positive. And therefore, sine is positive. Do you remember that deal where all of them are positive here? Sine is positive here, so then this must be out and this must be out. Right? Okay, finish this off. Draw your two triangles, and you'll have two answers, and they're different angles, because one of them is just a reference angle. Okay, so I know you're going to figure out that there's either 30s and 60s involved, but don't forget that this one is not a 30 or a 60 degree angle. It's all the way around to here, so it's more than just 30 or 60. And then make sure your answers are in radians. We've got to get this down. If you don't get this, you won't get inverse trig. Okay, so take a minute. I'm going to have you compare with the kid next to you and see if you can figure out what those two answers are to sine of theta equals a half. Pause while you give that a try. Okay, raise your hand if you have already compared with the person next to you. Okay, good. Then, here's what you should have been thinking. This one is sine is opposite over hypotenuse, and this is square root of 3. The one across from the 1 is a 30, and that's AKA pi over 6. And if that's 1 pi over 6 is one of the answers, the other answer is a whole bunch of pi over 6s, 5 pi over 6. Who had that right? Good. Now, let me make sure you understand the difference between that and this. What if I did sine negative 1, inverse sine of 1/2? It wouldn't be both of those answers. First of all, inverse sine also could be written arc sine. If you write the arc, you don't have to write the negative 1. Okay, and I think they did this back in the day when there was typewriters around, but there weren't computers. And so having a power of negative 1 was a difficult thing to write into a book, but you could type ARC really easily. Okay, so if you're handwriting out things or if you're typing out things, arc sine means the exact same thing as sine with a little negative 1. So I really, other than that, don't know why there's both ways. I just know that they mean the same thing and you'll get the same answer. Okay, so if I say arc sine or arc cosine, it means the same exact thing as if I put a little negative 1 right there. Okay, so what is the difference between this then, Mr. Server? Well, because this, remember me saying that we were going to have limitations? Like, we already limit it to 2 pi. We never go beyond that pretty much. You know what I mean? But now we're going to limit it in even more. And so here's the limits for arc sine, and I'll explain why in a minute. I think I've made a mistake in the past to have this really long explanation and then tell you the answer. I think it's better to just tell you the answer, and then I'll explain later why that's the answer. All right, so this, if there's only one thing you took notes on all hour and you memorized it, like if you had photographic memory, this would be the one, okay? Write this down, because you're going to use these every day between now and the chapter test, which is coming in about a week. That's pretty fast. This is where inverse cosine, I'm going to call it arc cos. That's where arc cosine is allowed. It's only allowed between 0 and what would you call this spot here? There's no debate about it. It's simple. If we're doing radians, it's what? Pi. This is pi. So arc cosine is only allowed between 0 and pi. No more between 0 and 2 pi. We go only between 0 and pi. Now, I'm going to go and show you where the other two functions are allowed to be. This is where inverse tan, or arctan, is allowed. And that, I think everybody would understand that this is pi over 2. So it's between pi over 2 and, wait, this is complicated, but not that complicated. Would you agree this? We would normally say this is 3 pi over 2. But there's another way to say it. Negative pi over 2, very good.
So would that line actually be closer to like our coastline? From the pi over 2 to the other?
Don't understand your question. Can you ask me again?
It's just like kind of small, so like it doesn't cover the whole graph. It's not. Is
All I'm trying to say is that the black one, arc cosine, was only allowed in this quadrant and that quadrant. And I'm trying to say that arctangent is also allowed in the first quadrant, but it's also the fourth quadrant. That's all I'm trying to say. And it's just hard to draw. You don't want to draw the lines right on top of each other. All right, so then last but not least is, like I can make it kind of in between, there's another one that's allowed between here and here. What's the function I haven't even ever said yet? Arc sine. Arc sine also goes between pi over 2 and negative pi over 2. We are restricting where we do these functions. It's no longer between 0 and 2 pi. It's different for each function. And what's the one different one? Cosine is different than the other two, and the other two are exactly the same. Well, pretty much. One of them can touch pi over 2 and negative pi over 2, and the other one can't. Do you remember how tangent has asymptotes and you can't touch the asymptotes? So that's a slight difference. Okay, so this green one, technically, if you're going to be really careful, it can touch both of these. And arctan is MC Hammer's favorite function because it can't touch this. Yes. Okay, why does it say 0 to pi? Well, those are just the places that those are normal. 0 is normally there. Pi over 2 is normally here. 2 pi over 2 is normally here. The only thing that's really weird is that should be 3 pi over 2 normally. So why are we doing negative pi over 2? Because if you zoom in on the graph, remember me saying I wanted to kind of keep it close to 0? That's where we're going to limit it. In the old days, you'd go between 0 and 2 pi. Now, we're getting it closer to 0, and so, all right. So for now, all I need you to do is understand that there's limits on inverse trig problems, and you can only go in 2 different quadrants each. They each get 2 quadrants they can live in. This is called the dead zone. I'd write this on your graph. I know it's dumb, but it's going to come up at some point. Somebody's going to ask you to do inverse trig over there, and you just get to say, oh, no solution, because you can't do it in that quadrant. Okay, and the next thing is this is the negative zone. That's a dead zone. This is the neg zone. That's the negative zone. In answers that are in that area are negative, and it's really easy to forget that. I would bet you money that that's also going to come up not only on homework but on the test, where you're going to have an answer that's in there, and you're going to be tempted to just say that it's like pi over 6, but it's got to be negative if it's in there. Negative pi over 6 or negative 3 pi over, no, the biggest it can be is negative pi over 2. So let's say negative pi over 3 or negative pi over 4. Negative pi over 2 would be that spot at the bottom. Okay. All right. So now I've told you those are the answers. Those are where inverse trig is done. It depends on the function. And what were we doing? We were doing inverse sine. Inverse sine, I just told you. Now you can totally look back at your drawing, but if you have photographic memory, do you remember which quadrants it was allowed in? So here is your process. And again, I told you before, if you only memorize one thing, it's that. But if you're only going to write one clean, crisp example of how to do inverse trig problems, you start with an inverse trig problem, then you convert it here to a circle trig problem. Sine of an angle equals 1/2, but it's not exactly the same as that, because this one would have infinite solutions, right? An inverse trig has got limits. It's got very strict limits. So I say but afterwards, because if you just write that, then there's infinite answers, and you don't want to be confused into thinking there's infinite answers. You want to only give one answer. Inverse trig problems are only allowed in 2 quadrants, and they are either positive or they're negative, so you're only going to get one answer. So many little pearls I've been tossing out about this unit. In inverse trig, there's special restrictions, which I showed you. And you're only ever going to get one answer for a inverse trig problem because it's only allowed in 2 quadrants, and one of the 2 quadrants won't work. Okay, so you're drawing one really nice example in your notes. Then where is inverse sine allowed? Did you memorize that it was only allowed from here to here? So then we're crossing this off and crossing that off. This is the dead zone, so you would have never gone there anyways. And if I end up down here, I got to remember it's the negative zone, so it's so easy to forget and give your answer as a not negative number, but it's actually negative if it's down there. But am I down there this time? No, because sine is positive, so then it can't be here. Because sine would be negative down there. Do you remember the ASTC thing? And that reminds you that sine is only positive in the top 2 quadrants, quadrants 1 and 2. So now I figured out where to draw my one triangle, and therefore I'm only going to get one answer. Sine is opposite over hypotenuse, and this is square root of 3. And what's across from the 1 over here? 30. And since I usually want radians, what's that? So the answer is pi over 6. If you would have done it this way, you'd have got 2 answers, pi over 6 and 5 pi over 6. Remember, we did that earlier this hour. We got 2 answers for it before. There's technically unlimited answers to it. But we have narrowed it down, and we're only allowing the one in the first quadrant, so the answer is just pi over 6. Okay, I'm going to give you one more like that. You ready? Arc cos of root 3 over 2. So the first thing you do is you say, well, that's the same as cosine of an angle is root 3 over 2. And that's a circle trig question. What's the next word I'm going to say? But it's only allowed, and then see if you can finish it. You can look it up on your thing you took notes on. Where is inverse cosine or arc cosine even allowed? Pause for a second and give that one a try. Okay, so did you confine cosine to only these 2 quadrants? Because that's where it's allowed, and therefore this is out and this is out. Did you realize that cosine would only be positive in the first quadrant, and therefore this is out? It's just a bunch of logic. Now this is my triangle. Cosine is adjacent over hypotenuse, and this is a 1, and what's across from the 1? It's a 30, and what's the same as a 30? Pi over 6. Who had pi over 6 as your answer? How many answers are you supposed to have? Only one. It's an inverse trig question. You're only going to have one. All right. Now, one more thing we didn't practice. I was going to before, but I never did. So I'm just going to give you a simple circle trig question of a quadrantal. Do you remember how to do what is sine of some angle equals 1? Hint, it has to do with one of these 4 spots. Do you see the 3 letters arc on this problem? No. Do you see a little power of -1? No. So is this an inverse trig question? No, it's not. This is not inverse trig. But I can get the answer for it, and then I'll show you how it could have been an inverse trig question, but it wasn't. This is 1, 0. Is that the spot? No, because sine is associated with which of the 2 coordinates, the x or the y? The y. So this is the spot. True or false? True. That's the spot, and that's pi over 2. And therefore the answer is pi over 2. But technically, I didn't give you any limits. I want you to see what this means. Sine looks like this. Goes forever in both directions. Do you get if sine is equal to 1, it's equal to 1 right there. But it's also equal to 1 there, and it'll keep happening forever in both directions. See what I'm saying? Without limits. All right, so why, when we do inverse trig, why do we get limited? I think I'm ready to teach you that part. All right, Zoe, can you slide back now? I'm glad you wanted to work together, but you don't need to right now. So here's why those limits are in place for sine and cosine and all that stuff. Okay, here's sine. You do not have to draw this, but pay attention. If this is sine, do you remember me saying that sine, picture it in your head, it was that first quadrant and the fourth quadrant, it was basically between here, Zoe, focus. Oh, it's not Zoe, okay, thank you. This is the two places it's between. Why is sine restricted to between pi over 2? Can you guys pay attention? This is really distracting to me. It's not complicated. You forgot why the pencil's going around, didn't you? Oh, good. All right. Has it been? Who hasn't had the pencil yet? Okay, then good. Then everybody has got a passion on their sheet then. We're good with that. Okay, now back to math. Ready? I can resume now. Okay, so why is sine limited to between those two spots? Because this is the only place where it'll pass the vertical line test and the horizontal line test. Now, I know this has been a long time since we talked about this. The vertical line test, you've known that since algebra, which is 2 classes ago. Vertical line test, you guys get that? It's a function, yay. But what about the horizontal line test? Horizontal line test was the one where if it passed that, then its inverse could be a function. All of a sudden, we're talking about inverses now, right? Inverse trig. So this is the only zone. See, if we allow it to go any further, do you get it won't pass the vertical line test if I let it out of that little box there? Sorry, the horizontal line test. All right, so I know many of you probably have forgotten that line test. It's called the vertical line test, tells you it's a function, and the horizontal line test, if I erase it like from here on, see, it'll pass the horizontal line test in that little zone. And that's why we only consider this zone, because this is the only zone where inverse sine will exist as a function. Because regular sine between here and here passes a vertical line test and the horizontal line test. That's why, if I draw it again here, that's why inverse sine is allowed to go from pi over 2 to negative pi over 2. And that's arc sine. So there's the big picture of why that's only allowed from there to there. Okay, now we're going to do that again, except with cosine. But you don't have to copy this down, just pay attention. Do you agree that's generally what cosine looks like? Now, do you remember that deal about wanting to pass the vertical line test? Well, it always does. And the horizontal line test. Do you get that this would not pass the horizontal line test if I just like let it be loose everywhere? So where did I say cosine? Yeah, or sorry, arc cosine could exist.
0 to pi.
0 to pi. Look, 0 to pi. To get in between there, it passes both vertical line test and the horizontal line tests between 0 and pi. See, that's why, and I know that some of you guys just want to know the answer, which is it only exists between 0 and pi. This is why cosine is only allowed to exist. Inverse cosine couldn't exist outside of this. It would start failing the horizontal line test. Okay. And last but not least is tangent. So let's ponder tangent for a minute. We just had a test on this, and hopefully you remember this is pi over 2 to negative pi over 2. And tangent goes like that. Does that ring a bell? Remember that? Okay. So, look at this. Will it pass the vertical line test? Yes. Will it pass the horizontal line test? Yes. So this one would be allowed to be from negative pi over 2 to pi over 2. That's exactly where I said inverse tan was allowed. Remember I said inverse tan was allowed from here to here? But remember me saying it couldn't touch MC Hammer's favorite function? Because it can't touch this. All right, so this is where inverse tan, or arctan, is allowed. And that's why. And that's why we call it negative pi over 2 and not 3 pi over 2. Because 3 pi over 2 is like way over here somewhere. Okay, question.
Why isn't arc cosine allowed to pass through negative pi over 2 when it's going from 0 to pi?
Okay, arc cosine is only allowed up here. Arc cosine's only allowed up there because it's from 0 to pi. And arc cosine, I'm going to show you the cosine graph again. It's right there. See? Because cosine, the only part of cosine, this is regular cosine. The only part of cosine that would work is between 0 and pi. That's why the only part of arc cosine that works, this is arc cos.
Remember the horizontal line? Like if you go past that.
Yes, but why can't it be flipped over and go ahead?
Why can't it go this way?
Yeah.
Because you'd be passing through areas where it cannot exist. Can't exist in any of those places. Okay. All right. So there's a explanation of why you've got to memorize these, but if I had to only have you memorize one thing, it would be, what's that again? Arc cos. What's this one? Touching? Careful. Touching. That's arc sine. And the last one's going to be in the exact same spot, except it can't touch it. And that's arc what? Arc tan. Okay, cool. Now, here's a typical question. Arc cosine of negative root 3 over 2. The first thing you do is make it into a circle trig question with a big but. But it's only allowed right here. Go ahead, give it a shot. Tomorrow I will come and pick this up again, where we need to understand what the graph of inverse cosine looks like. It's basically a lot like that piece of cosine that I showed you that would pass a vertical and horizontal line test. But we got to learn how to graph inverse cosine and inverse sine, and we have to be able to learn how to do nested inverse trig. So, yeah, bottom line, you'll get a review of this tomorrow, and we'll add 2 little pieces to it. I think your homework will be a worksheet. Haven't had a worksheet in a while. Okay. Leah, can you tell me cosine of, I'm changing it to circle trig. Perfect, except that would have infinite answers and this one doesn't. So you say, but, what's the but? You know how to do it, Leah? Okay, where is inverse cosine allowed? Okay, so I'm going to say it's only allowed here by going like that, and I'm going to cross these off. Okay, now, Charlotte, which of those 2 quadrants, quadrant 1 or 2, are we actually going to be in? Yeah, because cosine's negative. So therefore, that's out. Therefore, it must be here. If you haven't already, draw your triangle, label all your sides, figure out the angle, and the answer is the angle. The whole point of an inverse cosine or an inverse trig or any inverse trig question is to find the angle. All right, compare with the kid next to you. See if you get the same angle. It warms my heart to hear a lot of people saying it right. Cosine is adjacent, negative root 3 over hypotenuse, and that's a 1. And what's across from the 1 is a 30. I would have understood if somebody thought it was 30, but they're wrong. 30 is pi over 6. And then it's a kind of a bunch of pi over 6s. It's all of those, which is 5 pi over 6. Raise your hand if you had that one right. Cool. Okay. Then, I am going to attempt, see, last hour we watched the launch live, and so therefore we got knocked a lot of our time out. I'm gonna see if I can get you to understand nested ones. So let's see if this is a bridge too far. Nope, I already know it is. So I'm gonna just go right to the homework. We'll do the first couple homework problems together. And your homework is limited to just this page. You're only gonna do this page. I know this problem's after it. You're gonna skip those for now. We will come back to them later. So don't like destroy them or delete them. We're just doing this page today. All right, so let's zoom in on this first one. Now, if I were you, I'd probably put that thing I told you to memorize up here. Why don't you do that? Put the where is the inverse cosine and where's the inverse sine and where's the inverse tangent even allowed to be? I would draw that little diagram on the top because you're going to keep referring to it over and over, and this would be a great chance to like really lock that down. What's that one again, Henry?
That is arc cosine.
Correct. What's this one that is very purposely not touching these two spots? Graham.
That's tangent.
Arctan. And last but not least, this, which is very definitely touching both of them. Martin, you got that one? Arc sine. Okay. Good. And this one's negative pi over 2 down here, which makes that whole quadrant 4 the negative zone. And this is the dead zone. Okay. Good. Now that diagram will come in handy like a bunch of times. So here we are doing arc sine, and the first thing I told you to do is write sine of theta equals -1. But, and it's a big but, you can only do it in 2 quadrants. Vivian, where is inverse sine allowed again? Quadrants what and what? Correct. So these are out. And now arc sine is one of these two. John R., which of these two do I have to be in by logic? 1 or 4?
4.
Because?
Sine's negative.
Because sine's negative, I can't be here, it must be here. And now I can label all those sides. Lillian, sides are labeled opposites and hypotenuses and stuff. Tell me what to do. I'm trying to say these with the right words.
Would be opposite of your hypotenuse.
Good, so the opposite is?
I don't know.
Yeah, this is weird, isn't it?
Yeah.
Because there's a 1 there. So you're right, we're gonna get there. So this is opposite and hypotenuse, and what's wrong with that? Can you have a hypotenuse exactly the same as the other side? So don't think, oh, so there's no solution to this. No, it's one of those quadrantals. Do you remember sine can be -1? Think about it. You know sine can be -1, don't you? Think about the graph of sine. Can't sine touch -1? Sure it can. So it's one of those quadrantals where it must be here, 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 or here. So we've narrowed it down so much we know it must either be here, and it must be that answer, or here, and it must be that answer. Now, of those two, which one do you think it is? Well, remember circle 3. This is like 1, 0. This is like 0, -1. Which of them has sine being -1? The one going down. And is it 3 pi over 2? No. What is it? Negative pi over 2 is correct. Yay. Negative pi over 2. So, you know when you signed up for the honors class, you knew it was supposed to be hard? This is what hard feels like right here. This is like not that hard, but there's like 17 steps. I know you're feeling like it's not that hard. That's great. If you're getting this like it's like easy, like putting butter on some toast, awesome. You're going to like this unit. For some of you, this is going back over circle trig, and you weren't that good at circle trig in the first place, and then it's going to be really hard. Not trying to look at anybody in particular. I'm just saying there's some of you that had like a B- on circle trig. Well, that's why I said it was probably worth retaking that test so that you could really understand it, because here it is again. All these problems turn into circle trig questions again. The good part is maybe you'll get it down now. If you didn't ever have it down before, maybe you'll get it down now. Going on to number 2. I'm going to draw myself. Oh, wait, first I'm going to say sine of some angle is negative root 3 over 2, and that's a circle trig question. But this is an arc sine, and therefore only allowed over there. And of those two places, it's negative, so it can't be here. So then, I'm down to drawing a triangle here. And at least this one's a triangle again. The other one wasn't because it was one of those quadrantals, which you have to know a different way. Sine is opposite, an hypotenuse, and this must be a 1. And what's across from the 1? What angle's that? 30 down here. So that makes this a 60. But it's not a 60. It's a pi over... What's pi over what? 60 degrees? Pi over... Pi over 3 is what 60 is. In case you're forgetting that, I totally get it, but it's like that's 180. 180 divided by 3 is like 60. So pi over 3. But wait, what zone are we in? Neg zone. So it's negative pi over 3. All right. Now, this unit gets over with so fast that if you, right now, are lost, you need to fix that tonight by doing a bunch of practice problems, looking at the key, get this figured out, because this unit's going to be over with in about a week. And then boom, there's a test next week about this time, a little bit later maybe. So this unit is short, and it counts just as much as our 2-week-long units. So do your homework tonight. That's all I got for you for today.